The equation of motion of a body performing damped force vibration is d2x dt squared plus 5 dx dt plus 6x equals to cos t full stop. Solve this equation given that at t equals to 0, x equals to 0.1 and dx dt equals to 0. So we shall solve this equation by an determined method. And for us to do that, the first thing is for us to get the auxiliary equation of this equation. So it will be m squared plus 5m plus 6 equals to 0. Two numbers, when we add we get 5, when you multiply you get 6. The numbers are 2 and 3. Therefore we have m squared plus 2m plus 3m plus 6 equals to 0. So we factorize. When you factorize m squared and 2m, we have m, we take m out, we remain with m plus 2 plus the common factor here to be 3 into m plus 2. This equals to 0. So here, so we have m plus 3, and then we have m plus 2 equals to 0. Therefore, from here we have m plus 3 equals to 0, m1 equals to minus 3. Then from this, m plus 2 equals to 0. Therefore, m2 equals to negative 2. We also need to know that the equation of this, the solution of this equation is given by, the general solution is given by y equals to complementary function plus particular integral. So we are now calculating for this complementary function. Then once we have now m1 and m2, now the solution of this, the complementary function will be equal to, is always given by a exponent m1x plus b exponent m2x. Now that we have the value of m1, we have the value of m2, so our complementary function now becomes a exponent. m1 is negative 3, so it will be negative 3x, then plus b exponent m2 is negative 2x. So this is our complementary function, meaning that we have gotten this section, so we remain with this section. So we also need now to calculate for the particular integral. Once we get the particular integral, we shall add on this one to get the general solution. Now, when the equation will be given cos t on this side, so our assumed pi, our assumed particular integral will be equal to, it will be d cos t plus c sin t. So this will be our assumed pi. Therefore, we differentiate this equation. So we have y equals this, so we get dy. But remember, our variable here is x, so we are using x. Like this one is, this is x. We are using x. That is our variable from the equation. So we can say this is our x. Like that. So we get dx. Dx dt will be equal to, when you differentiate cos t, we shall get here negative d sin t, then plus when you differentiate sine, you get cos. So here plus c cos t. Then we differentiate this one for the second time. It will be d2x dt squared will be equal to, when you differentiate sine, here, when you differentiate sine, you get cos, but we get cos, so here it will be minus d cos t. Then when you differentiate cos, you get negative sine, so it will be minus c sine t. So once we have differentiated this, then we come back and substitute in this equation where there is the d2x dt squared, we replace with this one. Where there is dx dt, we replace with this one. Where there is x, we replace with this one. Okay, so our equation now becomes minus d cos d minus c sine t, then plus 5 into now our x dx dt, which is this one, minus d sine t plus c cos t, close the bracket, then plus 6 into our x d cos d plus c sine d, this one equals to cos d equals to cos t. So this will be minus d cos d minus c sine t. So we open the bracket, here we shall have minus 5d sine t, then plus 5c cos t, we are multiplying through, then plus, let's open the bracket, you have 6d cos t, then plus 6c sine t equals to cos t. So from here we shall group like terms, the sines and the cosines. Now this is cos, this is cos, this is cos, we put them together. So I can start with the positive, so I have 5c, this is 5c, then minus, this is d, I'm done with that, then plus 6d, then we put outside cos t, then I also have plus, now I have 6c minus 5d minus c, then we have sine t equals to cos t. So this we have minus d plus 6d, so it means that here we have 5c plus 5d, like that, cos t, plus this will be now plus 6c minus, it will be 5c, because we take 6c minus, we have 5c minus 5d, then sine t equals to cos t. Now we shall equate the corresponding coefficients of cos t. Now you can see that here cos t, the coefficient of cos t here is 1, the coefficient of cos t here is 5c plus 5d. Therefore, we shall say that 5c plus 5d equals to 1. The coefficient of cos t here is 1. Then because we don't have sine theta on this side, it means that the coefficient of sine t on this side is 0. Therefore, we shall have 5c minus 5d equals to 0. So we can solve the two equations to get the values of c and d. Now, so from this, we can say that 5c equals to 5d, meaning that c equals to d when you divide through by 5. Now if c equals to d, so we can come here and substitute here. Where there is d, we substitute with c, or where there is c, we put there d, so that here we have 5d plus 5d equals to 1. Therefore, 10d equals to 1. So from here you can say that d equals to 1 all over 10. Now after getting d equals to 1 all over 10, what will be the value of c? C also equals to 1 all over 10, because from here c equals to d. So once we have the value of d and c, we now go back and substitute in our assumed pi. Remember, our assumed pi was this one, that our particular integral was, now d is 1 all over 10 cos t plus 1 all over 10 sine t. Therefore, our general solution, we know the general solution is given by x equals to x, this is complementary function, plus particular integral, which equals to, we have, this is a exponent minus 3x plus b exponent minus 2x plus now the particular integral, which is 1 all over 10 cos t, then plus 1 all over 10 sine t. Now this is now the general solution. But from the equation we had been asked that we have been told that when t equals to 0, x equals to 0.1 and dx dt equals to 0. So from this more given information, we can be able to get the particular integral. We can be able to get the particular integral. What it means is that we can be able to get the value of p and a from the given information. So, so the given condition was that when t equals to 0, x equals to 0.1 and dx dt equals to 0. Okay, we shall start with this. These equations are saying that when t equals to 0, x equals to 0.1. Okay. And again, we should also be careful with the variable. So the variable here, this is the variable we have. This will be t. These are the variables. They should not confuse us. Those are the variables. The variable in this equation is t. So from here we can now say that we can use this and that. They are saying that when t equals to 0, x equals to 0.1. So this is x, so we shall say 0.1 equals to, so it will be a exponent. Now t is 0, so it will be 0 there, plus b exponent. T is 0, so 0 times negative 2 to be 0. Then plus 1 all over 10 cos 0 plus 1 all over 10 sine 0. Now 0.1 equals 2, so exponent 0 is 1, so here we remain with A, plus exponent 0 is 1 plus B, cos 0 is 1, so here we remain with plus 1 all over 10, sine 0 is 0, so this is 0. So from here we can say that A plus B equals to 0.1 minus 1 all over 10. 0.1 is the same as 1 all over 10 minus 1 all over 10, which equals to 0. So we are saying that A plus B equals to 0. Call it equation 1. Now, we shall be able to get second equation from when t equals to 0, dx dt equals to 0. So we need to differentiate this. We differentiate this equation with respect to x. So we shall get dx dt. So we differentiate this equation. So when you differentiate this equation, when you differentiate exponent minus 3t, we shall be able to get minus 3 a exponent minus 3t, then minus, when you differentiate this, we get 2b exponent minus 2t, and then plus 1 all over 10 into, when you differentiate cos t, you get minus sine t, and then plus cos t when you differentiate sine t. So this is what we have when you differentiate the equation. But they are saying that when t equals to 0, dx dt equals to 0. Therefore, we shall replace this one with 0. So we shall say 0 equals to minus, we are now substituting with the t, minus 3a exponent 0 minus 2b exponent 0. Remember, we are substituting to the 0 plus 1 all over 10 into minus sine 0 plus cos 0. So from here, we are saying that that 0 equals to, so this will be minus 3a minus 2b plus, this will be 0 plus, this is 1 plus 10 plus 10. So this is, remember when we are differentiating this, this was positive. So when you multiply with the, let's see here, we have, this is dx, we have minus, here, then you differentiate, so we have minus 2, then we have that, so we have minus minus 3a consider the equation here. Let's see how we are getting this. Minus 3a dx, then we have minus that. Minus and minus. Now our chain rule equation was x equals to a exponent that. So when we differentiate that, this is what we have. So here we have 0 equals to 3a 3a minus 2b plus 10. But from this equation 1, you can see that a plus b equals to, meaning that a equals to minus b, a equals to minus b from this equation. So we shall come here and say that 0 equals to minus 3a, then minus 2 into, this is now, we replace so minus a, so we replace, no, we shall replace a, so we have minus 3 into a is minus b, then minus 2b plus 1 all over 10 equals to 0. So here we have, this will be now 3, it will be 3, because negative and negative, 3b minus 2b equals to minus 1 all over 10. This crosses equal sign. So here we have what? 3b minus 2b will remain with b equals to minus 10. So if b equals to minus 10 and a equals to minus b, therefore a equals to positive 1 all over 10. So once we have the value of a and b, therefore the particular solution will be x equals to, we now replace a and b, so it will be x equals to 1 all over 10 exponent minus 3t, and then minus 1 all over 10 exponent minus 2t plus 1 all over 10 cos t plus 1 all over 10 sin t. Because 1 over 10 is common, we factorize it out. 1 over 10 into exponent minus 3t minus exponent minus 2t plus cos t plus sin t. Thank you for watching my video.